Okay, let's look at chapter 1. We're going to go through a few sections in this chapter. This should all be review, so I'll do some examples with you, and then I'll have you try some on your own. Let's get started here. Let's go over what an algebraic expression is. Remember, an algebraic expression is an expression that contains at least one variable. There are no equal signs. Okay, so 4x, 7x plus 2y. Those are all examples of expressions. Then we have orders of operation, PEMDAS. We'll go through what each of these letters stands for. P is parentheses, or any grouping symbols. This might be a bracket. Parentheses, fraction bars can represent grouping symbols. So always do what is in grouping symbols first. E is our exponents. M and D go together, multiplication and division. If multiplication comes first, great, do that first. However, if division does come first, you're going to do that. So you're doing multiplication and division from left to right, whichever one comes first. And then lastly, addition and subtraction, same deal. If subtraction is actually first from left to right, then start with subtraction and then addition. A lot of times people will just always do the addition before subtraction. Okay? So let's look at an example of an expression that we're going to evaluate. So we have x minus y all cubed plus 3. And it tells us what x equals and y equals. So we're going to literally just substitute that in. So we have 1 minus 4 all cubed plus 3. Okay, 1 in for x, 4 in for y. And now we do our order of operations. So I see some parentheses here. That means we'll have negative 3 cubed plus 3. Simplify that. Next thing is our exponents. So we're going to do negative 3 cubed. Remember, that means negative 3 times negative 3 times negative 3. That will maintain the negative sign. So negative 27. Remember, if you square something or raise it to an even power, your negative will become a positive. And lastly, we can now simplify negative 27 plus 3, and we'll get an answer of negative 24. Okay, you now try number 2. You can pause the video right here, give that a try, and then we'll continue on. Number 3, the formula for the area of a triangle with height h and base b is a equals 1/2 base times height. So hopefully you all remember that formula. It says write an expression to represent the area of the triangle. So remember, expression is just going to be, whoops, let me erase that real quick. Our expression is just going to be this part, okay, not the equal sign. So we're going to substitute in 2x for h and x plus 5 for our base. So we have 1/2. Our base is x plus 5, and our height is 2x. So there's an expression, and if we want to simplify that, we want to actually multiply through. Now, remember here that I can do whatever order I want here, so we could take half of this, but those are both odd numbers. So I'm actually going to take half of 2x, which is x, and then multiply x by x plus 5. And what that gives me is x squared plus 5x. And there's my simplified expression. Number 4, solve the formula for the specific variable. So they're saying, let's get this to solve for y. Right now it's solved for b. So we need to get y completely alone. What will be the first thing I do? That's right, we're going to add a to both sides. So add a. I now have x plus y over z equals a plus b, or b plus a. I'm just going in alphabetical order. Get y alone, so the next thing we need to do is undo this dividing by z. So to undo that, we will multiply by z. Remember, over here, we're multiplying, though, that whole quantity by z. So I now have x plus y equals, I like to put the z out front, z times a plus b. If you want to distribute it, you absolutely can. And last but not least, to get y alone, we now need to remove the x, and it's being added. So we will subtract it. So what do I get as my answer? I get that y equals z times a plus b minus x. And now I have solved for y. Okay, let's now look at section 1-2, properties of real numbers. For the first half of this course, we were talking about real numbers, numbers that you are used to, but we will eventually be talking about imaginary. So with our real number system, we have rational numbers, we have irrational numbers, integers, whole numbers, and natural numbers. Oftentimes, we are given letters to assign those. So you'll notice here, rationals uses a Q, because real numbers uses the R. So if you want to know the letters, you can. If you don't have those memorized, that's totally fine too. It's just a matter of whether you want to use them for shorthand. Okay, so our rational numbers are anything that can be written as a ratio. Notice we have fractions, right? Fractions are ratios. We have a decimal. 2, right? 2 is 2 over 1. So anything that can be written as a ratio. Repeating decimals can be written as ratios and fractions, so that's why they are rationals. Again, only repeating, non-terminating. Irrational numbers are values that have decimals that never end and are not repeating. So they don't ever terminate and there's no pattern to them. Those are irrational ones. And the most common one is pi. But like square root of 3, square root of 7, those will give you decimals that do not terminate and do not repeat. Integers are values that are positive or negative and don't have any decimals. Whole numbers include 0, and they're the rest of the positive integers. And the natural numbers are our counting numbers. They start with 1 and so forth. So whole and natural are pretty much the same, except whole, the way I remember this is it contains 0. And there's an O in whole, so I remember it that way. Okay? So then we have some properties of real numbers. Closure, commutative, associative, identity, inverse, distributive. Here is a chart. I'm going to let you review that. And if you have questions, of course, you can let me know. Okay, but those should all be reviewed. We'll do some examples of them below. So let's do some of these together and then you can try some on your own. Name the set of numbers to which each belongs. And again, if you want to use shorthand with Q, I, Z, W, and N, feel free to do so, or you can actually write them out as rational, integer, so forth. So negative 49, can I simplify that? I can. It's the same thing as negative 7. So what is that? Is that a rational number? Yes, it is. So I'll just write it out with words so that you have that for your notes. It's a rational number. Is it an integer? It sure is. Is it a whole number? It's not a whole number because it's negative. So it is a rational and it is integer. Let's do something like number 3, square root of 6. Is that a rational or irrational? And if you're not exactly sure, you can always put it in the calculator and we'll see that it is a decimal that doesn't stop and doesn't have a pattern either. It's not repeating. So what that means is that it is irrational. Once it's irrational, I'm done, right? Integers, whole numbers, and so forth are part of the rational values. So it's irrational, and that is it. Okay, how about number 5, 0.65, and that bar means repeating. So because it is repeating, it is going to be able to be written as a ratio. So it is rational. Once it's rational, we ask ourselves, is it an integer? And it is not an integer because it's a decimal. So it's simply just rational. Okay, you try numbers 2, 4, and 6. You can pause the video and give those a shot. Next, we have properties. And the properties that we're talking about refer up to here. Commutative, associative, identity, inverse, distributive. So if we look at these properties, we're going to ask ourselves here, what is the property that's being illustrated? So we have that negative 8 plus 8 plus 15 is the same thing as 0 plus 15. So what did we do? What changed? This is what changed, right? So what's happening here? And what this is we're adding. So it's our additive, oopsies, it's our additive inverse. Make sure that I write that correctly. Okay, it's our additive inverse because -8 and 8 are opposites of each other. Additive inverses are opposite and create 0. Okay, additive inverses are opposites of each other and create 0. Number 2, what's happening here? What's happened here is that this 2 got distributed. So this is our distributive property. Number 9, what's happened here? All the numbers are exactly the same, but the parentheses have changed. So when the grouping symbols change locations, that is the associative property. And number 10, what's happened here is that 5 times 1 is 5. When you're keeping a number exactly the same, that's an identity, right? An identity keeps yourself the same. In this case, I'm multiplying, so we have the multiplicative identity. With addition, to keep a number the same, we would have to have 0. So 0 is the additive identity. Let's talk inverses. As I said before, when we had an additive inverse, it was the opposite. We want to find additive inverses and multiplicative inverses. So an additive inverse is the opposite. I'll just write that right there. It's the opposite. A multiplicative inverse is the reciprocal. Okay. So additive inverse of -8, the opposite of -8 is +8. The multiplicative inverse is the reciprocal. So the reciprocal of -8 is -1/8. We don't need the opposite reciprocal. We just need the actual reciprocal. Okay. How about 0.25? Well, that would just be -0.25. How about the multiplicative inverse? What's the reciprocal? If it helps you, remember 0.25 is 1/4, right? 1/4. So now, what's the reciprocal of 1/4? It's simply 4. For number 13, opposite of -2/3, +2/3. And the reciprocal, keep the sign, but just flip, and we get -3/2. Okay, hope we're all doing okay with our properties of real numbers. Now let's simplify our expressions. We'll do one together, and I'll let you try the other. So when we're simplifying expressions, we need to make sure we are maintaining order of operations, and then we simply combine our like terms. So if I look here, I see some parentheses first. Well, can I do what's in the parentheses? No, because those are not like terms. So after that, any exponents? Nope. So then I go to multiplication and division, and I do see some multiplication right here, right? So I'm just going to copy -2x plus 9y. That comes down. But now I need to distribute the -5. So we have -5x. Remember, -5 times -6y will become +30y. Now I've done my multiplying, so I have adding and subtracting, and simply combining those like terms. So -2x is a like term with -5x, and 9y is a like term with 30y. So this will give us -7x plus 39y. And there's my simplified expression. I can't do anything more because these are not like terms. Okay, you try 15. Make sure to work with your fractions properly and then combine your like terms correctly at the end. Okay, hopefully you gave that one a try. Let's look at our next section, 1-3, solving equations. Hopefully you are good with this, but there are a few properties to just skim over These ones you should know from geometry. So we have our reflexive property, straightforward. What you have equals what you have. Symmetric property is where we flip-flop. Transitive property deals with three quantities. So if A equals B and B equals C, then the first and third will equal each other. Okay. Substitution, we use quite frequently. If X equals 2, then wherever I see a 2, I can throw an X. So let's name some properties and then let's solve an equation together. So naming our property here. What has changed? Nothing. So it is what it is. That means reflexive. How about number 2? What's changed? The order on each side of the equal sign. So that's our symmetric property. Number 3, 2y minus x equals 7 and x equals 3. Then 2y minus 3. So what we did here is we took that x equals 3 and we plopped it right on in for x, otherwise known as substituting it in for x. So this is substitution. Okay, let's solve an equation together. We'll do one with our fractions here. So I would encourage you to try to clear fractions while you're doing this. First, I'll distribute, but if fractions are not cleared, then I'll clear it. Let's see what we have here. So 3/5 times 15x. I know the 15 over 5 would make a 3, so this is really saying 3 times 3x, which is 9x. 3/5 times 20, right? Make sure to distribute. Again, 20 over 5 would be 4, so 4 times 3 is 12. Minus, distribute the 1/6, that would give me 3x. And remember, you're still distributing negative here, so that will become a positive, and that would be positive 2. So our fractions are completely gone. I don't need to do any more clearing. Now I will just combine my like terms, right? Get your x's together. That's what we're trying to solve for. So 9x minus 3x is 6x, and then 12 plus 2 is 14. To get x alone, we want to isolate it, so we will subtract 14. That means 6x will equal 24. And last but not least, to isolate 6x, we'll divide by 6. So 24 divided by 6 is 4. Now, it does say to check your solution. So what does that mean? It means to plug that back in. And I will let you do that to make sure we got the correct answer. After that, why don't you pause the screen and try number 5 on your own. Make sure you're distributing negative signs correctly. Okay, number 6. Number 6 says write an algebraic expression. So remember, an expression does not have an equal sign, but it will have variables and operations. So the difference between the product of 4 and a number and the square of the number. So difference means subtraction. Product, multiplication, and the square means to square it. Remember, square root is different from square. So the difference between, so we're going to start with the product of 4 and a number. So the product of 4 and a number means something like 4x. You can use any variable you want, but it just says a number, so we need a variable there. So multiplying 4 and a number, and I want the difference between that. So we're going to subtract now. We're going to subtract the square of a number. And it's that same number. So the square of that number is x squared. And you can leave it just like that. Okay, last but not least for this unit section of notes is 1.5, solving inequalities. So we're going to solve and we're going to graph. A couple of key things to remember, what the symbols obviously mean. But the big difference is when there's a line underneath, that means it's equal to. So when we graph, we have a closed circle because we want to include it. Whereas if it's not included, it's an open circle. Okay? Solving inequalities is going to be similar to solving equations. But I do want to have you remember one thing, and that is that when multiplying or dividing by a negative, what do we have to do? We have to flip the symbol. Okay? To flip inequality symbol. Really, really important. Okay, so let's look at maybe 2 of them together, and then I'll let you try some on your own. So we'll look at number 1 together. We want to solve and graph. So we want to get our variables to one side. And I always like to get it to the left-hand side because when we're reading inequalities, it's nice to have the inequality on the left-hand side. So that means I'm going to bring the 2y over here, and I need to subtract it. So that gives me negative 6y minus 3 is less than 2. I'm going to now add the 3 over. So I get negative 6y is less than 5. And divide by negative 6. So y, remember here I'm dividing by negative 6. So what do I have to do? I have to flip the symbol. Is greater than negative 5/6. So there's my solution, but we want to practice writing that in set builder notation. So here's an example of that. Our variable this time is y. So we have y such that y is greater than negative 5/6. When I sketch that on a number line, right, that's how we're going to graph when there's just one variable. We sketch on a number line. Okay. We know it has to be greater than negative 5/6. You can literally just write negative 5/6 and so forth. Or if you like to write it with integers and then approximate, you totally can do that. So I'm going to just have negative 5/6 here. What would be over here? Would negative 6/6 or negative 4/6 be over here? Negative 4/6, right? Because that's actually a larger value because it's less negative. And then negative 6/6, aka negative 1, which is probably better to put, but would be over here. I want you to make sure you have at least 3 numbers written on your number line so we know which direction we're going in. Let me get a different color now to plot this. All right, let's take here. If it's gonna let me. Okay, so we're greater than. So that means I'm gonna have an open circle. And if I'm greater than, I'm larger, so I'm getting more positive. So there you have it. You can also just draw it right on the number line if you prefer, especially if you have 2 colors. That's definitely an easy way to do that. Okay, so I wrote it in set builder notation and I graphed. Let's do another one, okay? Why don't we do number 2? With number 2 here, we have a fraction, but don't let us scare you, right? We're just like division. So to undo that, we're just going to multiply by 5. Multiplied by a positive, whoops, I should put that right there. Multiplied by a positive, so nothing changes in terms of symbols. But I get negative 15x is less than or equal to negative 4x plus 22. Remember, I like to have that variable on the left-hand side, so I'm going to bring over the negative 4x, which means I'm going to add 4x, and that will give me negative 11x is less than or equal to 22. Divide through by negative 11, and I divided through by a negative, so I need to remember to flip my symbol. There's my solution, but let's write that in set builder notation. X such that x is greater than or equal to negative 2. And when I graph that, negative 2 on each side, negative 1, and negative 3. I'll grab a different color. And again, I'm greater than. So it's included this time though, so I'll have a closed circle right on negative 2. And I'm greater than, so I want everything to the right. Okay? You try number 3 and number 4. and then submit those notes. I hope that helped.